So as you might have experienced or heard from other folks in the community, that we have to, as a Kubeflow community, we have to really work on the data science experience. In my experience and a lot of other my peers' experiences, that we have done a good job marketing Kubeflow to the DevOps and ML engineering engineers community, but we have long list of tasks we have to do in order to make it good for the data scientists. When you think of it, like data scientists are the kind of the large community of end users of Kubeflow, and we want to make sure the experience is good. And this we have like an amazing list of panelists here, and they are kind of experts in kind of data scientists and machine learning. And we wanted to hear from them, like what they do and how we can make their job more effective. And please ask questions. Like when I ask questions, like you can ask follow up, and we'll later we will open up to the audience so you can kind of ask questions. So be more interactive, be more informal. So let me kind of quickly introduce each panelist, and I will also I want each panelist to introduce themselves about their current role, and also kind of answer kind of a simple trivia question like, as a data scientist, like what's the one tool that you can't live without? Kind of briefly, you can talk about that. So, so from my left to right, we have June, who is a director of software engineering at Twitter. Then we have Ting Chen, who is a director of applied machine learning at Tencent. Then we have Emmanuel Ameisen, who is a head of AI at Insight Data Science. And we have June Andrews, who is principal data scientist at Delphi Data. Then we have Caio Soares, who is a group manager for data science at Intuit. Then finally, Scott Leishman, principal engineer at Intel. So why don't we start from June, like kind of explain your background, your kind of a one tool that you can't live without.
Cool. Hi, everyone. So I'm June. I used to be a data scientist, now running a team of data scientists and engineers at Twitter. On the revenue side, our main goal is to try to use technology and data science and machine learning to figure out how do we drive revenue more scalably. The one tool will have to be Jupyter Notebook.
Same, actually. Jupyter Notebook. Yeah, this is something we cannot live without that. And I'm currently a director of applied machine learning, Tencent, and building business models focused on medical AI, healthcare.
Hey everyone, I'm Emmanuel. I was a data scientist in a previous life, and now I'm the head of AI Insight, which is basically an education program or professional education for people that want to transition to data science and ML roles, and they come and do data science work there. So I say the one tool that I can't live without, and I try to make other people at Insight not live without, is probably actually Matplotlib. Seeing things matters. So yeah, really excited.
Yeah, I'm going to follow suit on this. It's going to be something with Jupyter plus visualization. But I'll have the reasoning. And the reasoning is because when everything goes to hell and you're like, oh gosh, what's going on? Is not only can you load it up and it's so much easier to debug with, but it also gives you a sense of joy. Like, oh, that's why I like doing this. This is actually some good stuff that we've got going on. So it gives you the joy to get through the tricky problems. I worked on a variety of applications, everything from growth to feature stores to airplanes and power plants.
Hi, I'm Caio Soares. I was a group manager for data science at Intuit, and a few months ago, I actually started leading a team of ML engineers to build for data science. So I've got sort of a foot in both worlds. I was going to echo the notebook sentiment, but for me, pandas is a must live without. I have to get around data and do everything with data, and so that's at least a starter point for me.
Hey everyone, I'm Scott Leishman. I'm at Intel currently. I came over as part of the Nirvana acquisition. So I've kind of swam upstream. Traditionally, I did more fraud modeling, credit card fraud detection, risk modeling, house price valuation, things of that sort. But over time, I got more and more into the software side. So I did work on Neon, And then now I actually do more Kubernetes, accelerated device enablement for Kubernetes. So the one tool I can't live without, I'll also go visual on this one. I'll go TensorBoard.
Cool. Good to see you. TensorFlow related too. Yeah, like Jupyter Notebooks has been like kind of a very kind of a tool that's very ubiquitous. So, but now like everyone can have Jupyter Notebooks or other forms of notebook. But so given that you have those tools that you love, what's the kind of the biggest frustration in the current stack that you use? Or like what's the kind of the thing that is holding you back when you want to move fast? Anyone can pick that up.
I can go first. I think my answer won't come as any surprise, and that's data. I think the more we move into the cloud, the more we can do, but that's not always a good thing. When we were on-prem, usually had very sort of tight down, lockdown data warehouses and few ways to represent data. And then folks want every pattern available for their need, rightly so. But now when you're trying to join data from S3 with data from relational database with a key value store, and this across systems and platforms and environments, and worse yet, multi-clouds, it's a mess. It's a hellacious mess. And then to try to do that and deploy that in production in a way that's stable and somebody's going to monitor, it's just really difficult. And so I think while the move to the cloud brought us incredible flexibility, incredible capabilities, it also now requires everybody to have a level of expertise of how to deal with all of those different systems, especially around data. That just makes life difficult.
Anyone wants to follow up?
First, I actually very much agree. I think data, or even figure out where everything is, or the documentation on what everything is, as far as data goes, is definitely something that's preventing us from going faster. A lot of time is spending on figure out those questions. Related to that, I think also not just data scientists, but even on the engineering side, similar observation too, is the ability to either not reinventing the wheel or decide whether I need to build my own wheels. I think a lot of times, like in feature engineering, especially in the larger size company, there are different teams working on similar problems, have solved this problem somewhere in the organization, but the awareness of this wheel has been built already once, and also the sort of context provided for any data scientist to decide whether this is a case where I need to build my own wheels is something that is not well solved a problem.
So is anyone of you don't have this problem? Like two of us said, like this is the biggest problem. For anyone of you, if data is not the biggest problem.
I'm actually gonna branch a little bit from what you said earlier. Is that when I'm going into a new problem, I measure how hard it is based off of the graveyard of previous attempts. And in the last 4 years, I have not attempted, or I have not been brought in to work on a project where there wasn't a significant best efforts graveyard. And when you have a graveyard that big and that many of them, it's not one thing that causes them all to fail. They all fail in new and interesting ways. Either it's resourcing, it's appropriate design up front of this is what the ML can deliver and this is what's actually needed. Sometimes there is a disconnect there. Sometimes, very rarely, well, data is always going to be a headache, but is it the difference between a project being a success and not is actually, I'd say, only a fraction of the time. There are so many other avenues under which projects can fail, and they can fail in new and interesting ways. So I think that's one of the biggest challenges, is that when you're going into a new area, is to be respectful that folks have probably done a great job of surmounting what they can on the data side, bringing in what they can on the architecture side, bringing in what they can on the infrastructure, but somehow it still doesn't come together, and understanding that you might need something new to overcome that. So I'd say the biggest challenge is you don't, the challenge from one project to the next is not the same. And the other thing I want to highlight is that speed and success are two different things. Success means you got it across the finish line. It actually delivered the value that was intended. And speed can sometimes be a foe in that realm. So there we go. We've got graveyards, variety of things, and I'm sorry I can't predict the future of why the next one's gonna fail.
So, like when we're talking about data, if you look at majorly two things, right? One, you're taking raw data set and kind of extracting features and making it into a usable form. The other one is that you already have data and you wanted to kind of do this feature extraction, like what we talked about in the feature store, where people wants to add features to existing model and kind of improve the model. Like how much effort for a data scientist is spent in those areas versus actually doing training? Because if you look at the current Kubeflow stack, a lot of importance is given to training. Like TF job is a big part of Kubeflow. The other systems like Feast, which is kind of a catching up. But like from a time spent perspective, how much time a data science spends on training versus kind of data preparation versus feature engineering?
I can comment on that. In my experience, majority of my time is spent on data preparation. So modeling part kind of relatively easy than that. We can just select models. When data and the labels are ready, we can throw into the library and do the training. So for the data, I want to add one more comment to the previous discussion. One challenge that I was facing is like the experimentation environment and the production environment are very different. So for example, I was working in Uber previously for fraud detection. And in the fraud data set, a lot of labels are written afterwards. And that means a lot of data get rewritten. And what we need to do is go back to that timestamp and change that label. And so that there are a lot of manual work is involved. That means we cannot guarantee or the experimentation environment is the same as the data that flows into the production environment.
So how does so we have a lot of infrastructure engineers. Like if we were to ask from them, like okay, build this magic tool that solves this problem, what would be that? Like how do you describe that tool or what it should do?
It would be infinite in size, so infinite compute, infinite data. The data is replicated across all your devices. That would be nice.
But it's like what does that infinite compute give you? Like if the data is the blocker, how do you solve with the infinite compute?
Yeah, I actually find it should be a compute-bound problem, right? It shouldn't be a data-bound problem. Once you've gone through the hard process of feature engineering and processing and prepping. So once your data set is kind of cleaned, analyzed, ready for modeling, right? You should be able to feed that as fast as possible. And it should be a compute-bound problem. But there are the compute devices that people tend to use. These accelerators are scarce. They're expensive in some cases. The barrier to entry is pretty high.
I think it's sometimes a knowledge and expertise problem as well. Data scientists don't necessarily care or want to know that you need a certain size cluster, you need a certain number of nodes, you need GPUs or CPUs or throughput and I/O, and they just don't care. They just want to say, here's my data, I want to train my model. Hide all the other stuff from me, I just don't care. Because that's not the part that's most often interesting to them. Not in all cases, but often cases. And so I think they can get frustrated with just a lack of knowledge of what to run and what kind of infrastructure. And they wish it was more of a, hey, I just want to run my job, take care of everything else for me.
There's one other aspect to that, and it's not just a stationary problem in time where it's like, I have this data, it goes into this model, yay, I'm done. You have to integrate over time what that value of the model is, and your features wander and change over time. And that's a whole nother kit and caboodle. And you also need to retrain your model continuously and redeploy seamlessly. So the ask on the infrastructure side would be, if I were to spend time to create these marvelous features to get the model to this performance on this point in time, how could you guarantee that going forward? And that you need a whole suite of support around feature monitoring, model retraining and deployment. And that's where you really care about your model train time, because part of the cost of these models is how much it costs to build them. So if you need 1 week to train your deep learning model to deploy it every 24 hours, that's pretty expensive. So integrate the cost of the feature, the model, and then integrate how valuable this is over time. And the really hard nugget to crack is that these are viral systems that tend to deviate, and they can either become better and better over time, or they can go downhill. So taking expertise at one point in time and being able to project it into the future would be marvelous.
Emmanuel, I want to hear from you. Like when you meet with a lot of kind of the new generation data scientists, right? So what do they think about when they first time encounter these problems, and they also look at the current infrastructure to solve that problem? Do they like feel, oh, like there's like a good enough infrastructure exists, or they say, oh no, like especially people coming from different domains like physics and other chemistry, right? They see that, oh, like in my domain things are much more mature, but in data science, machine learning, I don't see the infrastructure is not mature.
Yeah, that's a great question. I'd say, yeah, the infrastructure definitely is not there, or at least in their worldview. I think there's a huge information overload when you're back to sort of what you were talking about when you're a data scientist, and if your favorite tool is a Jupyter notebook, that means that maybe you got a CSV of data somewhere, like you got some extract, and then you generate your features, and maybe you structured your code well, and you have nice functions, and you've got your features generated, and you've like trained a bunch of models, and then maybe you've accounted for a feature drift. You've trained your models on a bunch of different CSVs of different times. You're like, oh, this looks pretty good, and in your mind, or at least in the mind of most junior data scientists, and you're done. But that's probably 5% of the work before you have a model in production, and all of the 95%, I think the biggest problem is that it's very much a you don't know what you don't know problem. And so that's probably the biggest blocker we see, where people will be like, okay, so how do I deploy my model? And then, you're like, oh, hold on, let's sit down together for 8 hours so I can explain Kubernetes to you. And it's like, okay, this is not going to work out. So I would say that that's sort of why platforms like maybe SageMaker or maybe Kubeflow and others that are trying to bridge that gap between, like, hey, you have a notebook, like the gap between having a notebook and having a REST API is the one that's the biggest, and the one that I think people care about the least. And so that's the sort of big thing to fix.
Yeah, and going back to Scott, so your comment about like we need to abstract, like even running it on GPU or some specialized accelerators like TPU. Like right now, things are getting better, but like still they have to make a change. Like some things are not supported in GPU or TPU, or like even like if they're going like a lower precision, they have to change the code. How do you think that the tool should kind of solve this problem for data scientists? The ideal situation is like what you said, but how do you think it gets there?
Yeah, I think part of it is knowledge. So you can't just be siloed as a data science. So you do have to take effort and start learning the side. And there's no shortcut to learning. It takes time. It's what I've seen over time, since I started, it was much simpler then. Your tooling was the programming language of your choice. That was where you started, and that's what you developed your model in. Now they've built all these layers and abstractions, but you've got to kind of learn those curves. And you always need an escape hatch to break down to a lower level when things don't go right. So that's another very important part. You can't just kind of live up in this high level. If you really want to understand what's going on, debug what's going on, it's 100% necessary. And I guess there's no shortcut to it. Yeah.
Okay. So talking about the infrastructure, like more of one trivia question. How many of you tried deploying Kubeflow by your own? Have you? Or so you? Two, can you share your experience, like as a data scientist, first time you're seeing Kubeflow, and what you got out of it? And
yes, I'm probably the wrong person to answer, because I'm probably more sided with the audience these days and spend more time kind of developing things like Kubeflow. I think it's pretty impressive. Like when I look back historically, when I started building models, it would take us a whole team of people to convert and put something into production or spin something up. Whereas now I can sit at my laptop and do it today in a matter of minutes. So I think people here deserve stand up and take a bow. Just how far we've come over the years. I actually have had a good experience installing Kubeflow. Fairly straightforward. Sure, documentation could be more plentiful as always, but I was able to get something up and running fairly quickly.
Good. Ting, do you
You want to hear the truth?
yeah, I think.
I actually spent the whole day reading all the documents and look at all the online tutorials and spend all the time download everything needed and also register a free Google Cloud account so that I can run the GPU there. But unfortunately, when I went to the deploy step, I stuck there and it tells me something like I needed to increase my quota, but I think this might not be the Kubeflow issue. It's more like a Google Cloud issue, and I just cannot find a place to do that. So that's where I stuck.
So
yeah. So my feeling is there are so many different tools and different libraries I need to install, and then there's no a very clear entry point. I can direct dive in like Jupyter Notebook. I can just open the website and I can start coding, right? But for this one, I need to set up all the environment first, and if one thing is broken, it stop me from doing anything else. Yeah.
Any follow-up questions in the audience? If you have mic.
Can I just yell it?
I think it's better for the people remotely to use mic.
In the project Kubeflow, we try and understand, examine personas and the roles, and somehow that sort of confluence between data scientists and DevOps. And so comments about the favorite tools and data scientists sort of not really wanting to understand or know much about the underlying layers. Personally, I find it surprised they wouldn't care about GPU type activities in like a TensorFlow Python script. But yeah, just wanted to get your thoughts on is it really so siloed, I guess, with respect to data scientists? Is there sort of the notion of personas that the community could sort of take away? Or is it sort of as restrictive as this is ops, this is the data scientists, it's all siloed. So just wanted to get your thoughts on that.
I know.
So I think I have poignant opinions on that. First of which is in every single company you go here in the Valley, when you say, what's a data scientist? They have a different definition. It's an ML engineer. People don't even have an ML engineer. So I think the spectrum of what's a data scientist, what's an ML engineer is wide and highly overlapping. Perhaps less so with DevOps, although now I hear things of like ML ops or AI ops, which now probably overlap heavily with ML engineering. So I think that the spectrum is wide. But I also think that it's hard to build a tool or a platform that pleases everybody, right? If you do, congratulations, you've done something incredible. But that also takes a lot of effort in having both flexibility as well as usability. And it's hard to have both. They at times go against each other, right? And so a great example that I have is we built a platform in which we were targeting data scientists, and part of it used Spark. So they actually wrote 400 distributed jobs or parallel jobs, something that Spark itself does. This was in an interaction with Kafka, and it almost brought down Kafka because they were all reading the same event. Now, from a data scientist perspective, yeah, that sounds like a great idea. I'm going to parallelize all 400 of my jobs. That should go faster, right? But it just goes to show that when you're targeting different personas, different functionalities should target different personas. It shouldn't be, here's a functionality, everybody use it the same way because we expect you to have all the same expertise. So I think you have to keep that in mind. Usability is a big thing. Flexibility is a big thing. And when you allow for both, it's where documentation comes in. That's really important. Sometimes you've got to be able to warn your user, like, hey, be careful with this. There's a lot of power here. These things could go wrong.
To layer that to the persona question, if I had to break down personas specifically for infrastructure, I'd say that you could roughly do it in 3 ballparks of the folks that are coming from computer science that have built sections of production infrastructure themselves and have a pretty good understanding and are very comfortable developing in a production environment. They know how to safely do that on a regular basis. Then you've got folks kind of in the middle, like myself. I come from supercomputing, and I've got some colleagues that come from physics, and they're used to working on physics clusters, and they know like how production systems work, and they'll tie their shoes 10 times before they touch it. And we really like having our own dev environments and knowing that when we are going to spin up a Spark job that we haven't checked twice, that, yeah, maybe we bring down the dev environment, it's okay. But then when we go to production, we know that we have to go through another set of checks. And then you have another persona of the folks that don't know the difference between dev and production. And you might want to have some special checks in place there. But from those personas, I think that breaks down how much power the user is expecting. The folks that are used to building everything themselves, they're going to want to be a mechanic on a Ferrari. They're going to want to be able to specify this is a hex bolt or this is a bolt with 7 sides. The folks that love to do the rough just approximation, see if it works in dev environment, and then we'll shine it up to go into production. They're going to want some tuning, but not too much. And then the folks that don't know the difference, less is better.
So talking about like personas and abstractions, right? What are the abstractions that you feel like the data scientist we shouldn't abstract them out, but let them kind of learn? Like, for example, like is Docker something that like the whole container concept should we hide from data scientists, or let the data scientists to learn about it because it might help them in the longer term? So kind of talk about like some few of those things that you might have seen, like either your team considering learning or like kind of avoiding it learning and feeling the pain later in the stage.
Just to piggyback off the personas, I think for the folks that do know the difference between dev and production, it is worth getting them up to speed on Docker, because they're going to run into problems like Descartes is having with not having nice communications between containers and understanding how to hierarchically layer the libraries that they're building so that they work nicely with containers and consequently the deployment of containers. And the reason you want to bring them up to speed on that is because then they can reformulate the ML problem to work inside of that those constraints. There are different forms of parallelization, and how you define your ML problem will need different types of parallelization. For the folks that, again, don't know the difference between dev and production, no, I would not bring them up to speed as to how Docker and containers work. For those folks, you really want the best way to handle those folks at the companies I've worked at is to try and understand what the canonical problems are, and then to build the specific infrastructure pipeline for releasing on those problems. So if inside of your company, let's say growth is a big one. So a lot of folks are going to have to do models around what is the growth of this part of the site, what is the growth of this, what is the growth of that. Okay, break that down to a canonical problem. Okay, so we need to release that model because it goes into these other things and makes productions. Okay, so then you can break it down to a minimum UI of what 20 different folks that need to do growth projections rely on. And then when they press button, yes, you do a nice deployment, ideally to a side production environment just for these types of canonical problems. But then they have no idea where those servers are, how they connect to other things, etc. So that would be my advice.
That's good. So June and Ting, like you kind of have a fairly large company and with a lot of different data science kind of a team. So like some of them are coming from stats background, some of them coming from other science background. So in your experience, how do you see these personas and what kind of abstractions that each personas get and they don't get?
Thanks. I may have a slightly biased opinion here, but I do believe that we should not be building tools that's so abstracted out that we're treating people in a fairly static way. I think if you have someone who don't know the difference between dev and prod, eventually they should be. If we build the tools, encourage them to feel comfortable in that zone, then eventually you will have bigger problem for the community. So I think we should do abstraction, but we should also leave that option open. If people want to tinker around, that should be given as an opportunity instead of just treating them as babies and always treat them as babies. And then slightly beyond that, I think the persona side of things is also interesting. I think there is definitely like specific type of profiles of talent coming from different backgrounds, but I think eventually it should be we should provide the opportunity for them to sort of go to different layers and learn and understand the problem so that everyone have an equal opportunity to sort of pitch in to solve this problem globally versus rely on the infrastructure engineering team to solve the complete infrastructure problem without having to have the data scientist side of the business worry about performance issues or just writing things parallel, assuming there is infinite computing resources.
Can I add to
Yes.
that? So I'm going to respectfully disagree a little bit.
Sure.
At Intuit, and this is my one company plug. Sorry. There's a part of Intuit culture that's about delighting the customer, right? I think one thing you always have to ask is who's your customer? Is it a data scientist? Is it an ML engineer? Is it a DevOps? And you build to that. I think it's the wrong question to ask of should a data scientist be expected to know Docker or insert any technology in here? I think the question is, if data scientist is your customer, that's who you're catering to, how easy can you make their life? How much can you delight them, right? And what they care about doing. Now, data scientists, like engineers and DevOps and anybody else, they're smart people. Can they learn Dockers? Of course. Should that be a part of their normal life cycle that they care about, that's important to them, that they need to know, that's core to them? Well, maybe so, maybe not. And I would say it's more likely that's in the maybe not, because that's a very deployment engineering type of thing, right? So data science go learn Docker. Okay, great. Now they've made a Docker container with a massive jar that's unmaintainable. And so it's not so much that can they learn a bunch of things, it's that the more we expect different personas to learn things that are not necessarily core to what they're trying to achieve, you've taken away from where they really want to focus their expertise. There's pros and cons to that.
I'll follow up on one more thing. Of the more requirements you push down on the stack of data scientists, the more likely you are to have resourcing as a problem. Hiring data scientists is getting easier and easier. Thank you. But it is if the more requirements you put on a role, the harder you're going to make it on your life. And in some cases, we just need an army to approach what we have to tackle. And on the other side of why things fail is sometimes you just have to work with the people you have.
Any audience?
I just want to say I agree, because I've been working with many different clients, and sometimes there is a huge part of the tech industry which I would argue is much bigger than like this hyper tech industry we all work in, which would not be able to do most technical roles, like very technical data science. So they still want to be able to do modeling at some level, but like I've worked with clients that are analysts, but they don't know how to use text editors, and like it's just not. This doesn't mean they can't do their job. It just means they need the right tools.
Anyone else from the audience to follow up? There's a couple of questions I can. I'll take the mic to the.
Hi, I would like to repeat a couple of keywords and I would like to see how you like to answer it in a way you observe it. One thing mentioned is graveyards. Second thing is expertise domains, right? And some is the, do I repeat it? So one is the graveyards because of unsuccessful attempts. Second is the expertise domain for a data scientist. Third is mainly we may need a lot of army of data scientists for some use cases. And the last word is AI hub.
I actually don't know. Yeah.
So I think we
not
haven't
hop.
discussed about. Yeah. So any
Graveyard. If you work at large companies, they'll have quarterly goals of we need to release these types of things, and then at the end of the quarter, they'll review it and say, "Did you hit that?" A graveyard is it was on the roadmap. It had resources, sometimes internal, sometimes external. This was the budget that was allocated to this problem, and it didn't meet the requirements. Oftentimes, when it doesn't meet requirements in the ML space, that means it's completely rolled back. There's no such thing as hitting it 50-50. So that's a documented graveyard. Another form of a graveyard is startup land. And then, sorry, was there, I think all the other buzzwords were.
Yes, about experience. I guess I can talk about that. It kind of gets back to the data scientist personas, right? If you think there's a big spectrum of data scientists, especially with the current kind of hype curve and cycle, there's more and more people entering. And so it's a bit of a challenge, right? What works for somebody that's just getting started is not going to work for somebody that's been doing it for 10 years. So that's something else to kind of think about as you kind of look at user personas. So the experience is broad. I guess that's the short answer.
Jamie.
Yeah, so I guess my question would be, if you're trying to set up an organization to use ML effectively, how would you organize the organization, right? So specifically, we've mentioned, let's say, ML engineers, DevOps folks, and data scientists, and sort of one implicit model. I forgot your name. Caio's answer was that you sort of set it up as a customer and service relationship where the infrastructure team is providing a service to, let's say, the data scientist teams. But like another more approach would be like an interdisciplinary team approach. So do you have thoughts on like what you think is the most optimal structure for an organization that's trying to be successful with ML?
Let me just quickly. What's the size of the organization?
Yeah, is ML part of your competitive advantage?
Why don't you take that however you want to take it?
Having worked at both, a small 6-person company and a large 100,000-person company, I've seen kind of both sides, and what works for one is not going to work for the other. For the small company, I think generalists are what you want, right? A couple of key hires. When I was at Nirvana, not only was I doing, machine learning, I was also doing IT. I was also doing, HVAC repair. You need to be kind of well versed in a lot of different things. And then at Intel, obviously, there's whole teams that are responsible for all these different things. So it really, really depends on the size of the organization.
Definitely, there's a division for HVAC.
On that note, there's a new mindset that I'm trying to think about in terms of how do you bring in data. And I want to think of it not as data enabled, which is your client service relationship, not as data driven, where data and ML is its own standalone org and reports into the C-suite, but so much as data competitive. What does it take to be competitive over time? And for that, you have to understand, why is this business going to be a success? If you have that knowledge, then you understand better how ML needs to fit into that picture. If your company, now the interesting bit that we'd all love to be at is if ML is going to be part of your competitive advantage, if ML is going to be part of why you are successful, then you can create and justify creating an environment that empowers ML. And in that sense, then you're closer to the, okay, let's think of ML as its own organization. Yes, it needs to interface well with the other systems of the body, but it can be something that you invest in upfront. The way I like to think of data competitive, here we're going to go off the rails for a little bit, is to think of Usain Bolt. Usain Bolt has a sense of taste. He has a sense of taste that is exactly enough so that he can test the food that he can eat to feed his muscles. He has no better sense of taste than that. In fact, he's absolutely notorious for only eating McDonald's when he's in China. But what is his competitive advantage is his muscular system to make him go really fast. So in that sense, I think data and ML needs to view itself as one of the systems of the body. It needs to interface really well with the other systems. And if you can actually make it work seamlessly with your biz side, your sales side, that I think gets you to the starting line to give you a chance.
So, Emmanuel, you kind of brought up similar thing where you have different needs for ML infrastructure or different ML deficit if depending upon the team size, right? And you deal with a batch of new kind of grads that are graduating that are time limited, and how do you see, like, and especially like if the team size is small, like what do you see the main requirements?
Yeah, this actually ties in really well with your question as well, which I think, so working at Insight, as you said, work with a bunch of people that are transitioning into data science and ML engineering and data engineering and DevOps, but also, we've been around since 2012, so we get to chat with a lot of alumni, and they come back and they tell us about all of their horror stories at all of the companies in the Bay Area, including some represented on this panel. I won't share names, and sort of a lot of these horror stories are about what they get to do and whether they're happy with their team structure or not. And there's been this sort of common trend over the past, I'd say, like year and a half, which is that companies that are large enough to be able to afford to have a platform team can then enable their data scientists to be what's sometimes referred to as a full stack data scientist, which actually means the opposite of a full stack data scientist, if you ask me, which is that they can just use very powerful abstractions to control their model from the prototype. So they can even like monitor the logs, see the TensorBoard in production, and if something fails in production, they also have very powerful tools to like help them debug it, right? But they don't necessarily need to know Docker or anything. They just have a good platform team. Unfortunately, I'd say that only happens for engineering teams larger than 75, 100 people. And so all of the other smaller teams are left in the dust, where you'll hear a lot of data scientists or data engineers that sort of will complain about these various points, that they have to do everything and that they don't feel like they're growing in that direction. So what I would say is, bringing it back to the work that's happening here, that's one of the reasons that I think it's extremely exciting, is because, back to a previous question, I don't think any data scientist is excited to use Kubeflow because they'll get to learn about Docker. If they wanted to learn about Docker, they would learn about Docker. And I think they're excited about it because they're like, great, like finally I have some support to get me from the fun thing I built to actually impacting the business. Because they just want to get there, they don't really care how. And so I think that what's really exciting about this project is that it will empower smaller teams to have the same sort of freedom.
Cool, thanks.
Yeah. So in my experience, like I just put my personal opinion about this. So I think for a small team, and if the team is very business oriented, and given limited headcount, I would split team into analyst and the machine learning engineer, because if I don't have the headcount for ops maybe. So I think for machine learning engineer, because usually they have the very engineering mindset, usually they don't like think very deep in the business side. So I would like the analysts to take care of all the business thinking and do data analysis, maybe using tools like Hive or SQL queries, and then define the business metrics. And engineers will work on the whole like machine learning pipelines and do all the like models, including deep learning models. And in a lot of business, like for example, the healthcare and the risk management, usually the requirements is like when you give a predictive score, you also need to give a reasoning code. So for that case, I think a lot of business logic makes a lot of sense. I think the analyst or maybe some of the data scientists can take care of the very business-oriented layer of the modeling, but machine learning engineer should take care of the everything behind.
Thanks. We're kind of right on time, and let's give a huge applause to the panel here. Thanks. Thanks for taking time to come here and share your experience. We are honored to host you. Thank you.
Thank you.